Welcome to the 75th lecture of Digital Electronics. In this lecture, we will be dealing with parity generators and checker. Okay. So the main key point in this lecture is parity bit. Okay. So coming into parity bit. There are two types of parity. First one is even parity, and second one is odd parity. Now let me explain about a parity bit a little bit. So let me having a 2-bit parity bit checker, parity bit generator. So my inputs are A and B. Output, which is the parity bit. Okay. So 0 0 0 1 1 0 1 1. Now I can have two types of parity, even parity as well as odd parity. Now see, if it is 0 and 0, if I am going for even parity, my output should be equal to 0. Here 0 1, even parity means I should get even number of ones. So you should get 1 0, again you should get 1 1 1. Already even number of ones are there, so you should get 0. Whereas if you are going for odd parity, 0 0, no ones are there, so you add a 1 0 1 1 1 is there, so 0 1 0, so 1 1 is there, so 0 1 1, two ones are there, so you should add one more 1. That is regarding odd parity. Now if you are looking to the relation between these inputs and even parity, what will you get? Even parity, you will get it as A bar B or AB bar. And odd parity, you will get as A bar, B bar or AB. So basically this is A XOR B, and this is A XNOR B. This is XNOR. Okay. And this is XOR. So that is an introduction to odd parity and even parity. So here A and B are the two bits which is inputted to a digital circuit. Now here I should get even number of ones. So 0 0, no ones are there, so you can give the even parity as 0. Whereas if you need to get odd parity, you need to add 1. If you need to get even parity in the second case, you should add 1. Now that means this parity bit is an extra bit added with the data. Now one question: why this extra bit is added? Okay, reason for adding extra bit. Why extra bit is added? That is a question. Now coming into that explanation of that. Okay. See, suppose you are having a sender and receiver. Some data needs to be transmitted from sender to receiver. So while the data is being transmitted, there will be some disturbances, or there will be some loss of data. Okay. So how will you account for these two? For that we are adding a parity bit. Suppose if you are getting 1 0 0 0, if you are going for even parity, you will add a 1, and this entire thing, that means here this much is the 1 0 0 is the data, and this is the parity bit. Okay. So send this data along with the parity bit to the receiver, and at the receiving end check for the parity bit. Now if I am going for the even parity, in the receiver side you check for the parity bit. If parity bit is equal to 1 for even parity, then we can say that you have received the entire data. Okay. So parity bit is an extra bit which is given to the receiver to cross-check whether the original data sent by the sender is being received by the receiver. Now, to give a simple example of parity bit generator and checker. Okay. So here generator is on sender side and the checker is on receiver side. Okay. So let me explain it to the help of a 2-bit data. Okay. So I am having A and B as the input, 2 bits as input, and I am going for say even parity. Okay. Now I am having 0 0 0 1 1 0 1 1. So now this is the even parity, that is P even or parity bit. So 0 0 even parity it is 0 0 1 1 1 0 1 1 1, we should give 0. That means here total number of ones if you are reading together should be even. That is it. Now 0 is considered as even. Therefore the even parity you can write it as A bar B or A B bar. So what is it? That is A XOR B. Okay. So in the generator side, in the parity generator side, you should have XOR gate. A and B are the inputs, and you will get parity. Now, at the receiving side, coming to the receiving side, at the receiving end, you have A, B, as well as B. So you need to check that. Okay. So how do you check that? Here, since this is a 2-bit input, at the reception side, what happens? You will check for the parity bit. That is it. You will check for the parity bit. That is it. So again, you have received this A and B. Okay. And you check for the parity bit. Okay. Now, if parity bit is equal to 1, in the case of even parity, you can say that there is no error. Sorry, there is error. Sorry, if parity bit, there is, what happens? If parity bit is equal to 1, you can say that there is no error, right? There is no error. That means whatever data is coming in, you are getting it out. Now, whereas when P is equal to 0, what happens? You cannot say whether you have obtained the required data, because you can check only for 1. Check only for 0 is practically impossible. Okay, check for 0 and checking for data means it can be error sum. And if parity bit is equal to 0, you can say that the data is errorful. Okay, so that is an example of 2-bit parity generator and checker. Now in the next lecture, we will go with higher order parity bit generators and checkers. So we will deal with the 4-bit parity generators and checkers in the next lecture. So hope in this short lecture you have got an idea about parity bit. So what is parity bit? Parity bit is actually an extra bit added along with the data, so that when the data is being sent from the sender end to the receiver end, at the receiver end, if you are checking that parity bit, and if that parity bit matches with the type of parity, then you can say that the data sent by the sender, the entire data sent by the sender is received by the receiver. Okay, so parity bit is just a caution for error check. Okay, so that is the class from this lecture. I have explained a 2-bit parity generator also. In 2-bit parity generator, you are having 2 bits of input. So in the parity generator side, what we have is I have shown with even parity. So in even parity should be equal to 1 when A is equal to 0, when A and B are entirely different bits. So it is basically an XOR gate. So if you are generalizing it, you can choose XOR gate as a door to check the parity. Okay, or you can use XOR gate as a door check. Okay, so in the receiving end you will get A and B, and again there you check for the parity, and if the P1 is matching with P2, then only you can say that there is no error. Or another thing is that here parity matching means the value should be equal to 1. I have gone for even parity. So when even parity, that means when the value of the parity bit is equal to 1, you can say that there is no error. And whereas if the parity is equal to 0, there is error. That means we have checked for even parity. And if I am getting 0, if I am getting odd parity, which means that the system is having an error. Whereas if I am checking for odd parity, in the same case, you should go with other track. Okay. So I think you have got the concept of parity bit generators and checkers. Okay. So in the next lecture we will deal with 4-bit parity generator and checker. Thank you.